Imagine that you are in some ancient tribe or something somewhere, okay? You saw that keeping count of things would have been needed for you for some reason or the other. How much food you caught, how many animals you hunted, or how much, berries you picked. And you saw that, hey, somebody picks more berries and brings. It's like, hey, you picked 3 berries, you picked 4 berries, you put together, you're like, I have 7 berries. It's very important to know that number, right? And then somebody ate 3 berries, you're like, oh, I have only 4 berries now because 7 was there and 3 were eaten. This was important. Now let's imagine that you're the person in the tribe, okay, who's very like good at this. They're like, okay, you don't pluck any berries, you can sit in your room, but everybody will bring the berries and put it inside. You should tell how many berries are there totally, okay? And let's say somebody's coming giving you 2 berries, and you're like, maybe grapes or something, 2 grapes, and then you're like, okay, two. Somebody else brings 5 more, you're like, okay, 2 and 5, 7 I have totally. Somebody else is bringing some other number, like 10 more berries. You'll add that because you know addition now. You'll be doing that. But let's say that in one of those days, everybody is bringing the same berries. Like one of them is bringing like 3 grapes, the next person is like 3 grapes, next person is like 3 grapes, next person is like 3 grapes. Do you notice the difference between these two situations? In the first, it's like one person is bringing 2, another person is bringing 4, some person is bringing like 9, some numbers like that. In the other case, everybody's bringing the same number. Now, this happened to you enough days where everybody is bringing the same number. They're like saying, okay, here 3 berries, 3 berries, 3 berries. What will you do? Hey, wait. Don't tell it one by one. How many of you are there? Okay, 8 of you are there. I already wrote down the answer for that. You would have written it down because you're so bored. You'll be like, hey, whenever I add 3 plus 3 plus 3 plus 3 plus 3 8 times, I know that the answer is 24. You wrote it down somewhere because you're lazy. And you'll be like, hey, okay, 8 of you are there with 3 berries. Come, I know the answer is 24 already. You'll feel like the smartest person in that room, right? Now, it so happens that a lot of times in life, it's the same thing we have to add again and again. For example, just example, let's say you're some car company. I know I went from like ancient tribe to now modern tribe. And then over here, for a car, there are always 4 wheels. So let's say you have to get like 100 cars. How many wheels should you get is very clear, right? Each car has 4 wheels. So for every car, you have to buy 4 wheels, 4 wheels, 4 wheels, 4 wheels. You can keep doing this. If you have to buy like some 10 cars, 20 cars, 30 cars, it's always the same number of wheels. So whenever you have to add the same number again and again and again, you're like, you know what? I'm just gonna write down the answer because it keeps happening so often that I can just tell the answer from that table, which is where you might have heard that name. There are tables. There is a 3 table. What does that mean? If I have to add three times to it, 3 times I have to add 3. I know the answer is 9. I wrote it down. I already counted long ago. If I have to add it 5 times to each itself, like 3 plus 3 plus 3 plus 3 plus 3, I know the answer is 15. I wrote it down. How did they write it down? By counting only. They just wrote it down so that they can look it up later. Now, this is all multiplication really is. And they were like, okay, you want to add 3 plus 3 plus 3 so many times. How many times? 5 times. Okay, I'll come up with a new way to write it. I'll take that plus symbol and tilt it a little bit and I'll say, hey, 3, this cross and 5 if I put, what I really mean is, don't add 3 and 5 and tell me 8. That's not what I mean. It's not a typo. What I mean is that I want to add 3 plus 3 plus 3 like that 5 times. So I call it 3 into 5, right? And I can always look up the answer for it. It's 15. Now, one question, like I said, is you might wonder why bother doing this? Because so many times in life, you have to add the same number again and again. Also, when you remember these few tables, you can also actually do and find the repeated addition of many other numbers. So, you may have heard multiplication is just repeated addition, but it's a sentence, right? It doesn't mean anything until you deeply understand what it is. So, pause for a moment, put yourself in the shoes of an ancient tribes person and imagine that if you had to add the same number again and again, would you at some point write it down, the answer to it? And would you give it a name? Maybe you'll give it a different name, but that's what multiplication really is. So you kind of saw that multiplication is just our laziness where we wrote down some tables because we don't want to keep doing same addition again and again. You may even remember some of those now, maybe. Like you will know 5 into 4 is like 20. You might even know that, hey, 5 into 4 and 4 into 5 are both the same. You might know why, right? You add 4 plus 4 plus 4 plus 4 5 times, or 5, 5, 5, 5, 4 times. It shouldn't make a difference. Think about it if you haven't. So you know all this. But what about like some bigger number? You might have seen a method, right? See, you have a question over here. Do 23 into 3. This is actually some of the times when my students have said, what is this max, sir? I don't like it. So let's see, like, what's the scene here? What do they mean by this? And you might have seen, I'm just going to do the method that the way it's typically taught, okay? First. So we'll do 3 into 3, they'll tell like this, 3 into 3 in the ones place you do, and then you write 9 over here. Why and all, don't ask, because I won't tell you. And then you do 3 into 2, and then you write 6 over here. Whatever comes as answer, it's thrown to you by some entity, and you have to accept it. Why this works and all that is not, why is that necessary really? And then children are made to tell this is the correct answer. And then they are like, okay ma'am, so I should first take this number, multiply by this number, write it here. Then 3 into 2, I know 3 tables, so 3 into 2 is 6, I'll write it here. So, but there is a better way to do this, right? I'm sure you want to think about this. You just saw that multiplication and all is just a name given for, we don't want to keep adding the same number. So let's imagine what this really is, right? 23 into 3 means I want to add 23 to 23 to 23 3 times. There's another way to visualize it also. I can take 3, 3, 3, 3, 3, 23 times. Both are the same. I've taken it this way, 23 added to itself 3 times. Now what you're really doing when you do this method, see, like I told you, all these methods, if you have a lot of time, you don't need any of these methods. You'll start at 23, count 23 up from there. You'll go to somewhat 46 you'll go to. From there you'll count 23 more. You'll go to that 69. That's the answer. You have enough time. If you don't have time, these are just methods to help you fasten or speeden up your work. So what they're really telling is, hey, this problem can actually be seen this way. These two can be seen differently. What I mean by that is, hey, you have to add these, but inside that problem of 23 adding to itself 3 times, there is two smaller problems. Hey, you have to add 3 to itself 3 times because it's just putting together and counting, right? You have to put these 3 together and count. That is itself a repeated addition problem. If this had been 3 plus 4 plus 6, then nah. But it happens to be 3, 3, 3. And if you have to add these 3 together, you know that that's just 3 added to itself 3 times, that is 9. So you're like, hey, this should be 9. And then here you are, hey, it so happens that in every row, there is the same number of blue blocks, right? 2 here, 2 here, 2 here. Why is that? Because that's what multiplication is. But yeah. So you'll be like, yeah, I know how to do that. I have to add 2 to itself 3 times. That only we call 2 into 3. So that is like 2 into 3 will be 6. So I'll write this. 3 into 3 is 9. 2 into 3 is 6. Except, this is 9 blocks of just ones. So that's a 9. But this is 6 blocks of what? 10. So that's 60 actually, right? Because it's 10 blocks. And now you'll be like, okay, cool. I know how much is there totally. That's 69. Now, this is just a way of writing that so that we don't we follow some method and get some marks or something like that. But this is what you're really doing. So keep this in mind, and you can, whenever you're doing a multiplication problem, understand you're just breaking it into 2 smaller repeated additions and then doing it. And using the fact that you end up getting smaller problems which also have the same number of blocks to add. It's nice, no? Now, when you play with these, sometimes it's good to play with some tricky, slightly more complex examples to see whether we really get it. It's just to be curious. So let's say that I take something like 53. That's a number. And I want to add it to itself 7 times, which is what we call 53 into 7. Now, what would this really look like? We know that here I can break this into 2 problems where I first add 3 to itself 7 times, right? So 3 plus 3 plus 3 plus 3 will be how much? 3 into 7. If you don't know the tables of this, you can do it and count and then check, or you can look it up. The answer turns out to be 21 if you add 3 to itself 7 times. Or you can think of it as 7 to itself 3 times, 7, 14, 21. So you'll have 21, but you know that, hey, whenever it spills over, right, you have 2 tens and a 1. You can always be like, hey, I know that I'm going to have 1, and I have like 2 tens with me. I have 20 with me to add to whatever I get over here, right? Now I have 21, I've written 1 over here and 20 over here, right? Now you have 50 into 7, right? 50 added to itself 7 times, which is 5 blocks of 10 added to itself like 7 times. So you take a block of 5, plus 5, plus 5, plus 5, 7 times. Imagine how much that will be. 5 into 7 is like 35 blocks of 10 you will get, yeah? So 35 blocks. So again, it's going above 10. So I know that I have like actually more than 10 blocks of 10. So I'm going to have 35 blocks of 10. But what I really know is that if it's 35 blocks of 10, it's 5 blocks of 10. But the other 30 blocks of 10 are actually 3 blocks of 100, right? 30 blocks of 10 is the same as 3 blocks of 100. I know you know this already, but I'm making sure I say this. So then you'll get like 300 with you. That's all you've written. 300 is there and 50 is over here, right? Yeah. But then the problem is this 50 already had, there's another 20 over here. So you know that it's going to be another 20. 50 plus 20 is another 70. And then you have 300s and nothing else. So it's 300s, 70 and 1. 371. This can feel a little awkward at first. I remember struggling with this for a while because these are hard. Even though we understand it, it's kind of hard to do without making mistakes. We have to go look up some table. You might even get it wrong many times. I would say don't worry about doing this fast. Don't worry about doing this without mistakes. Now, it's okay to make a few mistakes. There are anyway calculators to do this for us. We're doing all of this more to really understand what these are and really know what we're doing when we're doing it. That's it. Okay. So when you're practicing, keep that in mind.